Today we're going to talk about function notation, and let's start off by looking at these four equations here, and let's talk about what is the same about them and what's different. So first of all, what's the same about all of these equations is the actual equation part, like the place where you would plug in x. Each one of them is exactly the same. It's 4x minus 7. So what that means is if you're using it as an equation, each one is going to give you the same answer. Each one is saying if you give me an x and I plug it in, I'm going to take that number, I'm going to multiply it by 4, and then I'm going to subtract 7. So what's different about each one is what's over here. One of them is y, one of them is f of x, one of them is g of x, and one of them is q of x. Now what those things are that I circled in red is basically the name of the function. And that's what we're going to talk about today, is we're going to talk about the difference between like y and f of x. All right, so if you're talking about a function, we can write it two ways. We can write it as y equals, or we can write it as, and I did f of x equals, it could be, I showed you on the last slide, it could be g of x or h of x or q of x, it doesn't matter. We're basically giving our function a name by assigning it a letter. Now the second way is called function notation. This right here, when you give your function a name like f of x or g of x or q of x, that's called function notation. And the way you would say that, I've already said it a lot today, but when you see a letter followed by the letter x in parentheses, you say that's the name of the function, f of x. And that's kind of a shorthand way of saying f is a function of x. So f is the name of the function, and x is the variable that you're using in that function. Now what we're going to focus on for today is just very simple how to use function notation to evaluate. So if I give you a function f of x and I said find f of 5, what I'm telling you is to plug 5 in for x. So let's do that. Let's take our same function here, f of x equals 4x minus 7, and let's find f of 5. Now what that means is you are taking the number 5 and you're plugging it into your original function for x, just like that. So what I would have, I'll leave the 4. Now instead of x, I'll put a 5 and I'll put it in parentheses because it's multiplication. And then we still have the minus 7 on the end. So all I did was I substituted. I changed the x into a 5. Now when you go to evaluate, remember your order of operations. Multiplication comes first here. So I would do 4 times 5 is 20. And 20 minus 7 would be 13. So the final answer, f of 5 equals 13. And you get that by plugging 5 in for x. Now that was a pretty simple example. You guys have done that before. What we want to do to take the next step is we want to show it doesn't have to just be a number. So you can do, like we just did f of 5, we can do f of something else, maybe something with a variable in it, or something with, an expression in it, or something with another function in it. Basically for the notes, I'm just going to use a square. You think of that as like a blank box that could be anything. So if I say find f of, and then there's something there, absolutely anything. What it means is take that something, whatever it is, substitute it for x, no matter what that something is, and then simplify. So let's change our example a little. Let's use the same f of x, 4x minus 7, but this time we want to find f of 2x, not just f of 5, not just a number, but f of 2x. So let me start, I'm going to recopy the original one. F of x equals 4x minus 7. I like to start with that. And then I'm going to find f of 2x. Now remember what that means. You take whatever you see here, it doesn't matter what it is, and you substitute it for x in the function. So I'm going to do the same thing I did on the first example. I'm going to leave the 4. Now for the x, I'm going to substitute what I see in the parentheses or in the original question, and that's 2x. And then I'm going to leave the minus 7. Now we'll finish it the same way we did before. We'll multiply first. 4 times 2x is 8x. We still have the minus 7 on the end, and that whole thing is the answer, 8x minus 7. So my answer isn't a number, my answer is a different equation. And that's a good way to think of it. A lot of times, most of the time, when you're using function notation, if you substitute a number, your answer is a number. So like when I substituted 5, my answer was 13. But when you substitute an expression, something with an x in it, your answer also has an x in it. So I didn't just get a number this time. I got an equation or an expression, 8x minus 7. Let's do one more. Same original function, f of x equals 4x minus 7. And this time I'm going to find f of 3y minus 1. So let's start the question the same way. I'm going to recopy the question, recopy the function. I like to have it there. And then underneath it, I am going to find f of 3y minus 1. So what I'm going to do, I'm going to take this 3y minus 1, and I'm going to substitute it right there for x. And what that would give me, I'll leave the 4. Now instead of the x, I now have 3y minus 1. And I still have the minus 7 on the end. So all I did was I recopied the original problem, but I changed this x here into 3y minus 1. Now, to finish out the question, it takes maybe one extra step on this one. I need to distribute the 4. I would have 4 times 3y, that would be 12y. 4 times negative 1, that would be negative 4 minus 4. And I still have that minus 7 on the end. Then you can combine your like terms. I'm going to leave the 12y, but the negative 4 and the negative 7 together give me negative 11. And that's my final answer, 12y minus 11. So that's what we're doing today. We're doing function notation. We're evaluating by plugging not just numbers, but different things in. So for today, we took our function f of x equals 4x minus 7. We did an easy example where we just plugged in 5. We did a medium example, we plugged in 2x. And then we did a little bit tougher example where we plugged in 3y minus 1. But the idea, if you look at the screen right now, they're all the same problem. Whenever I ask you to use function notation, you take whatever the thing I'm asking you to find is here in the parentheses. In this case, it was 3y minus 1. You go to your function and you change each x in that function into that thing, whatever it was, 3y minus 1.